Hello guys, this is part 2 of generating a level from a texture. So today we're gonna just continue our work on the script. So let me just maximize this. Let's remove the print thing from the generate level function. And let's begin by getting the color data of the pixels of the texture. So let's do that. So color 32, and that's going to be named pixels. We're gonna set it to texture to generate from .get pixels 32, and then we're gonna need another variable down here and call this. Let's call this text width. That's just the width of the texture. That's going to be texture to generate from width. And so let's create a for loop so we can go through the colors or the pixels. So let's say for int I is equals to 0, I is less than texture to generate from. Nope, that's not it. I is less than pixels, I plus plus. So this is just a simple for loop, and we need a dot length here. Yup. Alright, and so we're gonna check what the current pixel we're looking at's color is. So pixels I, and let's check if it is equals to, yup, that should work. And in here we will instantiate the tiles. We'll take care of the other objects later. So let's just print out, there should be a tile on this pixel. And let's see what happens when we play in Unity. Press G and there should be a tile on this pixel. So something's working. So let's continue. So first we need to define a position where we want to put the actual tile on. That's going to be a little bit complicated, but stay with me. So I'll just write this out and try to explain it to you afterwards. So vector2 pose for position is equals to new vector2 I modulus operator text width times tile size. And then for the y, we say I, nope, we need 2, I minus I modulus operator text width, and this is just the x coordinate, and that is going to be divided by text width, and then at last we'll say times tile size. Okay, good. Now we have the position. Now let's quickly just instantiate some tiles at this position, and I'll explain how this works afterwards. So instantiate tile prefab, and the position is pose, and the rotation is gonna be quaternion.identity, which basically is 0. And so let's go into Unity and see if it works. Press G and we got some tiles. Whoa! And that's pretty cool. So now let's get into the explanation of what the heck this is. So why does our line of code actually work? Well, let me set up a little pixel grid right here. Let's say it is 3 by 3 pixels big. So let me just put an index on these pixels. Let's say we want to find the coordinates for this pixel, the pixel with the index of 8. We know the width of the image or the pixels are 3. So text width is 3. So let's take our index of this guy right here and say 8 modulus operator and 3. So this should give us a number called 2, and this will be our x coordinate because we start from 0, 1, 2, and that's correct. So now let's look at how we get the y coordinate. So we just say x, and y is equals to 8 minus our x coordinate, which is 2, and this is going to be divided by the text width, which is 3, and this should give us 2. So why does this work? Well, let's see. What is 8 minus 2? Well, that's 6. And what is 6 divided by 3? That's 2. And 0, 1, 2. So by using the modulus operator, we can basically find the two-dimensional coordinates in a one-dimensional array of pixels. So our end coordinates are 2 and 2. Now in our code, we actually multiply these values by our tile size, of course. So that basically explains how we're getting the position. So let's continue our work. So let's, instead of just saying instantiate, let's create a local variable right here, and let's set that to be GameObject created tile will equals to the instantiated tile, and we will set the parent of this tile to be our levelGen object, just so the created tiles don't clutter up our hierarchy. So let's say created tile dot transform dot parent will be equals to transform. So let's go into Unity and see what happens. Let's press play and G. And you can see our tiles are now under our levelGen object. So that's cool. It doesn't clutter up our hierarchy. So what do we need now? Let's add this tile, the created tile, to our list of tiles created over here. So let's say tiles created dot add created tile. So we're gonna need this for adding grass on our tiles later. Well, now we're done with this right here. So let's continue to spawning something else than tiles. So to do that, we'll first set up a little struct down here. So go to the bottom of your script and let's say public struct. Let's call this object on pixel, object on color. And in this struct, there's going to be a game object, and that is the object we want to spawn on a specific color. So let's just call this obj for object, and then we're going to need a color, and that's going to be a color 32, I suppose. Oh no, that doesn't matter. Let's just say color, and let's call this color. Cool. And now let's make sure this is serializable so we can see it in the inspector. And now let's go up here in the top of our script and create a new public object on color. And this is going to be an array. And let's just call this objects on colors. So let's go into Unity and set this up quickly. So we want to spawn something on the yellow colors and the red colors. So let's go over here. And let's also quickly open up this in our editor of choice. And we have to know the exact color because else this won't work. So you can use the eyedropper tool and just click on your color and go in and copy the hexadecimal value. And let's go back into Unity and create 2 of these. What? We forgot to set them to public, so make sure to do that. And now we should be able to see something. Cool. So now we have an object we can assign and a color. So let's create an object real quick right here. So this is going to be a cube. And this cube is going to be 16 by 16. Now you can put whatever object you feel like on whatever color. So This is just to show you how to do it. So let's call this coin, but this is obviously not a coin. Let me just create a material, yellow, and this is going to be an unlit material. It's going to have a color of yellow. There we go, and let's just put this on the box. And this is our coin. Let's make a prefab. And now let's remove this coin. And now let's create another object, and let's call this player. And let's add another material on this player. Let's call this red. And this is going to have a color, which is red. Nice. And let's make sure the size or the scale of this object is big enough to see. Let's make a prefab. Remove it, and let's create our objects on colors. So we want to spawn the coin on the yellow color. So copy a hexadecimal value in here, and that's it for the coin. And now let's set up the player. So drag in the player object and set the color to red. Now let's make sure the hexadecimal color is the same as in here. So let's use the eyedropper tool and find out what color this pixel is. And it is the same. You can also see the RGB value is also the same. So let's just copy this and just paste it in here to make sure. Yep, it's all good. Well, now we have to set up the system. So let's go back into our code and let's create another for loop. It should not be in here. It should be in here. And let's say for int o is equals to 0. O is under objects on colors dot length o plus plus. We're setting this to be o because we can't use I, because we are already in a for loop which uses I. So let's check if the current pixel's color is equals to one of the colors on our objects on colors elements in our array. So o dot color, and then we simply want to instantiate the object we want on that color. So let's first get the position, and that's the code up here. So let's just copy and paste this, and let's say instantiate object on colors o dot obj, and this is going to be at the pose, and then we're gonna say quaternion dot identity. Good. So now let's see if this works. Nice. Well, this works. So now you can spawn whatever objects you want anywhere, and that's pretty cool. So now let's go and add grass to our tiles. So we're going to create a whole new function, and let's call this function void set tile sprites. Yeah, and we're gonna call this function after we've done all of this. So let's call set tile sprites. All right. So in this set tile sprites function, we just want to loop through every single created tile. So let's do that. For int I is equals to 0, I is under tiles created dot count I plus plus. So we want to check if the list contains a tile which is on top of the current tile we're looking at. So we will require another function, which will be a bool does contain, and this will take a list of game objects, and this will be called list, and a vector2 pose. So this will basically return true or false if the list contains a game object with this pose position. So we're going to loop through the list, And then we're going to check if list I dot transform dot position is equals to pose. So we have to cast this to a vector 2. And if so, we will return true. And if not, well, we will return false. So now we have this done. So now we can continue our setTileSprites function. So let's check if there is a tile on top. So if does contain, the list is tiles created, and the position is a new vector 2 tiles created I dot x. Oops, what? Dot x, and tiles created I plus tile size. Oh, and we have to put in transform.position here. So if this is true, well, then there's a tile on top. So we want to check if it is false. So let's put a exclamation mark here. That means that we're checking if this returns false. And if this returns false, well, then the tile sprite should be a tile with grass. So let's quickly check if this works. So let's say tiles created I dot get component sprite renderer dot sprite will be equals to top tile sprites. Let's just say 0. And let's go into Unity and see if it works. And we can see it works. So you can see there's grass on top, but now we're going to add the corner tiles, so there'll be grass on the corners. So let's do that. So we're going to copy this function, or this if statement, and paste it in. And now let's check if there is a tile on the left. So remove the exclamation mark, and if there's a tile on the left, then we will, what will we do? Then we will maybe set the sprite to be a right corner sprite. So let's see, minus tile size. So if there's something on the left, and then we want to copy this and put it in here. Let me just zoom out a little bit. Can I do that? Yes, nice. And in this one, we will check if there is something on the right. If that is true, well, then there's tiles on the left and right. So it will basically be a top middle sprite. So let's say tiles created I dot get component sprite renderer dot sprite will be equals to blank, top tile sprites, and then we'll pick a random sprite in this array, random.range, that will start from 0 and end at top tiles.length. And now we will check if this is false, so else, and then we will copy this. If this is false, then we'll put a right corner tile. So this is going to be a right corner sprites and right corner sprites. So this is actually pretty complicated. Bear with me, guys. So now let's check if there is no tile on the left, but there is a tile on the right. So let's check that. Copy this, and let's make sure there's an exclamation mark here. So if there isn't a tile on the left, but there is a tile on the right, well then we want the sprite to be a left corner sprite. So say left corner sprites and copy that over there. So now we're finished with this, and this was really complicated for some reason, but let's see if everything works. Let's press G, and it works. We can see we have left corner sprites and right corner sprites, so that works, and that is fantastic. So that was quite annoying to do, but I think it paid off. Look at this, guys. It looks amazing. I think it's pretty cool. So now we're finished with this, and I hope you find it useful. So yeah. Thanks for watching. I hope the series was helpful. And also a big thanks to my first Patreon, Philip Andrew. If you want to support the channel, please consider becoming a Patreon or subscribing. Thanks again, and have a good day.